Wunderschönen guten Morgen. Wunderschönen guten Morgen. Ich glaube, wir würden jetzt mal langsam anfangen. Good morning and welcome to our 9th Tech-Brunch. Today our speaker is Karl Singlein, who is a researcher at Creative Robotics, which is a unit within the University for Arts and Design in Linz. Many of you knew him before he came his long way from Australia to Austria due to his YouTube channel, where he is explaining robotics and co-PRC. And yeah, today he will be talking about his way, how he came into robotics, and about his work in creative robotics, and especially about the plugin developed by Johannes Braumann, who is also head of CR. And a personal note from my side, I'm really grateful that you're here and always helping me out with stuff and my robotics project and all the time-consuming troubleshooting. This thank you goes out to both of you, Johannes and Karl. Thanks a lot. Yeah, I don't want to keep you longer from Karl, but there's just one little thing. If you have questions during the talk of Karl, you can do that, but post them in Slido. You can join the chat with the hashtag Tech-Brunch, and then you can ask some questions, and after the talk, Karl will be answering the questions. So, I guess he will. So, yeah, have fun with our 9th Tech-Brunch. Karl.
Thank you very much, Miriam, for the introduction. That was really nice, and you stole my entire introduction. But as some of you guys can probably tell from my accent, I am not from Austria, I'm Australian. I did my Masters of Architecture at the University of Tasmania, where I was introduced to Grasshopper and parametric modelling and architectural design, which was my core focus across 2 years at the University of Tasmania. During that time, the workshop manager found out that I was focused on computational programming and grabbed me by the shoulder one day and came down and sort of said, come to the workshop and have a look at what we've got in there, which was a brand new unused KUKA Quantec, and said, did you know that you can use the Quantec, control the Quantec via the programming language that you've been teaching yourself over the last few months? Nobody here knows how to use it. Would you be interested in spending the time to get us up and running and be the robot guy? And of course I said absolutely. That was a childhood dream come true, just the idea of having my own $100,000 robot. So for the rest of my masters, you could find me in the workshop, sitting under the KUKA, laptop in hand, figuring out why the robot won't work, why it won't move, to which is why I end up here in Austria, because the person who developed the software I'm known for using is Johannes Braumann, the professor I am doing research with now, and I started emailing him asking, why won't the robot move? So the robots that we specialise in, and I specialise in, are industrial robotic arms that are designed and built for doing tasks such as automotive manufacturing and mass manufacturing, doing the same thing a million times on a factory floor. So they're six-axis robotic arms designed for pick and place, manufacturing, welding, really heavy duty lifting things. Sort of, if we compare it to a 3-axis CNC, a traditional 3-axis CNC, it's a machine designed to do a job, and then sort of they've been co-opted by architects and designers and people such as myself, and said there's more potential than just pick and place manufacturing in these factories, which is fantastic because of the nature of manufacturing. There is a lot of these machines in second-hand that are completely usable and great to have a second life. And with mass production, there's thousands. It's a pretty cheap barrier if you're interested in robotics in architecture as well as creative robotics to actually get involved. Traditionally, the simulation, the sort of access to robotics was very pragmatic. So back to the 3-axis milling of a traditional CNC, you would program the robot and it would output what you put in. It was very inflexible. So the way you do a printer, you press print, whatever happens, happens. If something goes wrong, you have to go all the way back to the start, just like a traditional CNC milling machine. There's very little flexibility. If something wrong happens at the very end, or when you're milling, you have to go right back to the start. So this is the traditional sort of manufacturing with the robot, or any sort of manufacturing with a CNC controlled machine. We can see that you've got your geometry, what you want to actually produce, the strategy, how you're going to make it, the simulation, and then finally you produce it. And in any step of something goes wrong, chances are you've got to go back maybe all the way back to the start, find where it's gone wrong, or find that you don't like it, or something that you've designed or developed hasn't gone well, which is very sort of traditional, sort of industry 3.0. So then the core question was, how do we adapt these robotics into a system that's parametric and we can adapt them to more flexible, creative purposes? So this was the KUKA PRC sort of approach that Johannes developed, where instead of it being a rigid linear design path, it becomes a more parametric approach where there's modules. If you update or change something throughout the process, we can then see the results immediately. So using Grasshopper, which is the software that KUKA PRC runs in, you can immediately update your design, update your code, see the workflow go through instantaneously, and get immediate feedback before you even send it to the robot. So Grasshopper is a parametric software that a lot of architects have been picking up over the last 13, 14 years. And KUKA PRC primarily exists in there, where we're able to develop designs, or basically whatever we can imagine, and then have live data feedback going back and forth from the computer, even to the robot, where we can update the robot while it's doing something live through real-time data feedback, as is demonstrated by the robot updating as the line is changing. So these machines were specifically designed to do 1 million actions one time. The other way around. These machines were designed to do one thing 1 million times, but through the use of parametric software such as Grasshopper and our approach, now we're flipping it and we're trying to do it 1 million things once. So the benefits of what this sort of approach is that now systems and ideas that were really common in manufacturing and not so much in construction and architecture is that we are able to now do more creative things at different scales, actual one-to-one rapid prototyping. So in this example, we've got a hot wire foam cutting, which was annoying, complicated, but with the access of a 6 or 7 axis robot, we're able to do it at large scale and do it fast. Thanks to the parametric do it, something goes wrong, something goes right, learn, adapt, and your model updates in real time. Flexible. You buy a $10,000, $20,000, $100,000 CNC machine, it does one thing, it does CNC. You invest in your robotic arm, you've got multi-functions, whatever you put on the end of a robot. The thing that I love about a robot, the way I introduce them to workshops and people, is it's a big dumb arm with no hand. No eyes, no head, no brain, it's just a dumb hand. And it doesn't know anything, it doesn't do anything, and half of the fun is you've got to come up with what you want it to do with it. So you've got to design the end effector, think about what the end effector is to do, and then program around how it's going to do what you envision it to do. A lot of people message me, thanks to the YouTube channel, ask, where do I buy my end effectors? And I just design them and build them and 99% of the time they don't work. So through the adaptation of this new technology and parametric design, we can now fabricate complex geometry that we couldn't before. Either it was impossible, too expensive, too limiting, but through parametric design and the adaptation of the physical through the robotics, it's now realizable. Not just for Frank Gehry or Zaha Hadid, but now even students can design and produce structures and architecture that wasn't previously possible. This is another example that was done with KUKA PRC by Branch Technologies in the States, that you can actually 3D print structures that will stand live on site using the robotics. And the code is scalable. So what we do on a small scale KR3, which is a little robot with about 600 millimeters of direction, you can take that code, scale it up to a KUKA Titan, which can lift a car. Completely flexible. And then there's always the output of the KUKA is very similar to CNC or G-code if you're familiar. And it's not in so much producing the code is the tricky thing. The important thing is how accurate the simulation is. Because if you can't simulate it accurately, it's not going to work, or it's going to do something unpredictable. So through that, after sort of my introduction to robotics in architecture, KUKA PRC, KUKA robots in general, I started to realize that, all this information is out there, or it's hidden. People are doing it, but not necessarily making it public. I was emailing Johannes probably once every couple of weeks with another problem, and they seemed rather trivial. Once you know the information, it's actually pretty straightforward and it makes a lot of sense. So I started demonstrating the KUKA at University of Tasmania. I would have groups come in once a week or a couple times a month, and just had the students sort of interact with the robot as well as producing their own drawings and giving them a quick introduction to the world of parametric design and fabrication. So this was sort of the kicking off point where I realized that, people are interested, and that it was worthwhile sharing this sort of information, which is why I started my YouTube channel, where I started doing tutorials, which sort of has now seen me visit 5 continents to do robotics, run workshops, talk, and it's been a fantastic thing, which actually was the reason why I got here. I now visit around the world. Last month I was in Mexico doing a workshop for 10 days. Last year I was in Peru doing the AA visiting school with a fantastic group of students, where a big part of what we do with creative robotics and a big part of my own sort of idea about it is to actually transfer the knowledge that we have. So a big part is to actually communicate, make it clear, and teach the potentials. Which brings us to Creative Robotics, which is our research group within the Art and Design University of Linz, which we operate. We have a space here in Grand Garage. Downstairs we've got a couple robots, as well as we've got a big Quantec over in the main building of the university. We're a very rapidly growing group, having won a couple grants this year. A big part of our core set of values is skill digitization. So through our knowledge that we've got embodied in robotics and parametric design, we're very interested in taking what people know and understand and then digitizing it to then be used by a robot. And this doesn't necessarily mean, a lot of people say, well, you're just doing what a human can do, but it's taking that knowledge and then taking the benefits a 6-axis robot does and seeing what it can bring to the actual skill. So there's things that humans are good at, and there's things that machines are good at. In this example, a project of Creative Robotics was to digitize traditional masonry work, chiseling stone, where when we mapped it, he didn't even understand what he was doing. The knowledge was so imbued in him, it was muscle memory. When we showed him the data, the video of what he was actually doing, he was visibly surprised because it just becomes emotion. So we took all that information, mapped it to a robot, and then the next step was we don't want to replicate what he can do because he does it perfectly already. But what can we do with access to a robotic arm? we can put in the 5th axis, 6th axis of motion and start doing the patterns, things that a human hand can't do. Another fantastic project by Creative Robotics was the last saddle manufacturer in Austria approached us and sort of said, we're the last ones remaining, we need to stay with the times and modernize. What's the research? How can we adapt this technology? So through Creative Robotics, we digitized their workflow, identified what they're doing and how the adaptation of KUKA PRC and parametric modeling may be able to add to it. And it was a big prototyping issue where to make a mold was a time-consuming thing, and you really only want to make a mold if you're going to use that mold, sell that mold, make a profit, which is fair enough. But through Grasshopper and KUKA PRC, it's possible to introduce rapid prototyping and then introduce new sizes, custom saddles, which were previously not possible for obvious reasons. Additionally, collaborative working with people with robots. That's the KUKA Iwa, which is their collaborative 7-axis robot, where it's got very pressure-sensitive torque values. We're doing skills or jobs that just aren't practical anymore for a human to do, such as polishing metal to a very fine degree. Very time-consuming, precise work that a robot can work alongside a person. As well as the construction industry. Obviously, my background is architecture. I look at robotics through the eyes of an architect, and I'm always thinking about, large-scale, one-to-one modelling. How can we, improve the built environment? So we've been approached by different people in industry. How do we incorporate the robotics at a parametric level within their workflow? So completing tasks that would normally be done by several different machines, CNC, hand, a robotic arm can then, have different end effectors, do multiple different tasks on site and be a lot more effective, a lot more efficient based on parametric modeling as well as the KUKA PRC approach. But we are called Creative Robotics. We don't only work with industry partners and research practical applications. People commonly approach us and just have an idea. It's a big part of my job, and my favourite part of my job is just having an idea, such as one that was done a couple of years ago, where we were approached and asked if we could develop a KUKA that could play guitar. And they asked for Santana quality, and then you very quickly realise that these on the ends of our hands are very, very complicated, and we take them for granted every day. So we had to come up with an idea of, is it possible to even get it to play a tune? How would we get it to play a tune? And where were the limitations? At the time, nobody in Creative Robotics actually knew how to play guitar, but thankfully one of the students involved did, and sort of took it away and sort of came up with the idea that if we had just a couple fingers on one of the KUKAs and then the stop on the other, we could make a decent tune. So initial prototyping of the 2 KUKAs playing the guitar in the lab. So I keep saying computational parametric design. The challenge in this was obviously you don't want it to do the same thing over and over. So a script was actually developed of a brand new way of reading and writing music that could be put into Grasshopper that automatically generated the guitar's movement so that you could do different music within the limitations of the project. This was for a festival, and of course when it came time to present the work, what's better than 2 robots? Always 3, always more, always more. So we mounted the 2 smaller KUKAs on a large KUKA. Additionally, we had McLaren, obviously a leading car manufacturer, approached us and just asked us what can we do to sort of really showcase the top end of technology when it comes to automobiles. So we got one of the most expensive cookers and said we'll just get it to dust it. So in their Zurich showroom, we wanted to use the robot just to showcase the car. Completely irrelevant, but lovely little project just to have the cooker there all day, all night, in the shop window, keeping the dust off the McLaren. Additionally, we have a relationship with Ars Electronica here in Linz, where they have the festival once a year, and we commonly provide a performance and installation or a couple. And this was our 2017 installation of a robot simply modifying geometry in a space, and was on a continuous loop that introduced a bit of live data and feedback into it, so it was always changing. So that was 2017. Each year we're invited back and we kind of get one really lovely open brief of what are you going to do this year and how are you going to beat last year. So from 2017, where we had one or two doing separate things, we were asked, can we go bigger? So 2018, we said, okay, we will have multiple and we will interact with them during the gala event. Video motion tracking and having her do the performance live so that on the day of the event she could actually dance with the playback of what she was doing in the studio. So through her motion capture, we developed a unique system that had never been done before of having the 5 cookers actually talking in real time to make sure they are millimeters within a millimeter of each other's performance. Otherwise it gets incredibly dangerous. There's chance of collisions or accidents. So this was a completely custom solution built by us. Oh, where I've lost the video, sorry. That's meant to be playing. Where the dancer actually performed twice, dancing with the robots, 2 different performances, because once the system was built and in the system, she could actually dance with her playback in front of a live audience with a live orchestra. And it was spectacular. And I'm very sorry I don't have the video working today. So I think that's it.
Thank you so much, Carl. Do you have any questions for Carl, maybe? Do you want the mic?
No, I think yeah.
Too afraid of questions?
Hello. Do you plan something for the Ars Electronica Festival in 2020? Maybe
Yes.
with 8 robots or?
That's my worst nightmare, to be honest. After the stress of 5, the funny thing with the Ars Electronica Festival is people watch it and they're very impressed, but they're like, oh, and yet I'm like, I just want to see the robots. But absolutely, we'll be there. We're there every year. Hopefully 10.
Fine, thanks.
So that's a very interesting question. What about actually the safety issues? We saw dancers, and how do you handle safety?
Very carefully. Obviously, these are industrial arms and there is a lot of safety around them. What we do in a performance is very different of what we would do with a workshop or with people that don't know. These are very choreographed, and sometimes we are ignoring some very big safety issues, but it's always in a very controlled environment.
Did you have any connections to the healthcare industry? How to use robots there?
No. No, there's a big industry and a big approach for robotics in the medical, for obvious reasons. I know KUKA has a whole startup sort of...
But because the robots which are now used are very restricted, okay? They are very specialized and can only be used for special activities, okay?
Mm-hmm.
And I think that's a restriction which is not necessary, okay? Good, okay.
Any more questions?
Nope.
Okay, so thank you so much, Carl. So I think you will be around.
Yes.
So if you come up with some questions, I'm sure you can answer them during the brunch. Yeah? Okay. Thanks again.
Thank you very much.